Do you feel the vibes?
Alrighty, so let's go to 12.3, tangent lines and velocity. Okay, so we've been talking, you've been asked to find slope, since you were, I don't know, very little, right? And, it's like, okay, y2 minus y1 over x2 minus x1, but we never really think about what slope is. Slope is rate of change. Oh, so slope is rate of change. So most things change, right? Some change quickly, some change less quickly, some change even more quickly. The rate at which something changes is slope, right? So for example, if your car, right, if you're accelerating your car, right? So if you're going from, let's say, 0 to like 60 miles an hour, how long it takes for that to happen, that's rate of change, okay? If, I don't know, you find some new video game, right? And your math grade drops from like a 97 to like an 83, the time it takes for that to happen, that's rate of change, okay? So, okay. It is the amount y changes with respect to a change in x. So whenever I ask you what is slope, the response should be its rate of change. It should be like super quick. What is slope? Rate of change. What is your name? Blah, blah, blah. What is slope? Rate of change. Okay? Now, so if I go, on the x-axis from one point to another point, if there is this much change in the x-axis, how much change does that correspond to in the y-axis? That is rate of change. That is slope. Okay. To find slope on a linear curve like this, it's very easy, right? You take 2 points. So suppose we wanted to find the slope at a specific point, 3, 5, this point right there. I wanted to find the slope right there. One thing I can do is I can take 2 points near that point and find the slope of that one. So if the highlighted point is where I want to find the slope, I can find 2 points close to it or around it, find the slope of that, and that's, the slope at 3, 5, right? Now, how did you find slope when you were younger? y2 minus y1 over x2 minus x1. Fine. So now, if this is x1, the y value for that, we always called it y1. But y is also f of x. So I can also, call it f1 of x, or I can call it f of x1. And then if this is x2, that y value will be f of x2. So instead of doing y2 minus y1, I could just, use calculus notation, and I could do either f2 of x or f of x2 minus f of x1 over this, okay? All right. This is really basic and simple when we have a linear curve, because no matter where I look, the slope is always the same. What if I have a curve that is not linear? In this case, if I'm at different points, the slope will be changing. So for example, if I'm at this point, this is the slope right at that point. If I'm at this point, the slope right at that point is something different. It's more or less steep than another point. So if now I was asked to find the slope of this curve at the point 1, 1, okay, right there, that's that point 1, 1. Now, in green, okay, that's the point right there, okay? That's the slope over there. When you extend that line, that's what it looks like. So the slope at that particular point should be the slope of this green point. So what you say, you're like, hey, this worked for the one above. Let me just pick 2 points and find the slope between those points. So you pick 1, 1, all right? And then you pick this point over here, 3 comma 9, like a whole 2 units away. That's the line between those is that red line. You find the slope of that. How similar is that to the one with the green? Right? Not, I mean, So you're like, okay, that's a little bit off, right? So you're like, okay, why don't I just move this point closer to the first one? So you move it closer to the first one. Now, you take the slope between those 2 points. Now, what was the slope here? That's this one. When you find the slope of those between those 2 points, you realize, okay, look, that got a little bit closer to the actual slope of the green line. So you're like, oh my God, I'm really onto something. So now, why don't I pick a point even closer right there so that the distance between the 2 points isn't a whopping 2 or a 1. It's not even a 0.1. It's even like less and less and less. And you see, by making that distance smaller and smaller, the slope between those 2 points is actually becoming the slope of the line that you want. You see that? So how did that happen? It happened by reducing this distance to a very tiny amount and making it almost 0. Okay? So let's go here. When we had, the 2 points, right? And we were finding the slope between the 2 points. This was x1. This was x2. And suppose the distance between them, let's call it h. Okay? So now, when the points are far apart like this, and I draw a line connecting them, that line is passing through the curve at 2 points, correct? That is called a secant line. Eventually, I want to bring those points so close to each other that when I draw a line between them, that line only crosses the graph at 1 point, and instead of a secant line, it becomes a tangent line. Okay? So, how do I do that? I do that by making the points super, super close. So let's derive this for a minute. If this point is x1 and then I go an h distance away, the new point is at x1 plus h, correct? Or, you know what, let's not do x1. Let's just do x and x plus h. So this is, the y value there is f of x. The y value here is f of the new point, x plus h. So now, if I wanted to find the slope of that secant line, it's going to be y2 f of x plus h minus y1 f of x over the second point minus the first point, x plus h minus x. So that's really f of x plus h minus f of x over h. This is the slope of the secant line, and this is a famous equation, right? Now, to make this line into the tangent line, I have to bring the 2 points closer. As I bring the 2 points closer, are there any questions? As I bring the 2 points closer, h eventually becomes how big? 0. Okay? Now, I'm never going to make h exactly 0. It's going to approach 0. So whenever anything is approaching anything, that's a limit. Okay? So now, to get the best approximation, bring points together. Okay, we bring the points closer. That means h will approach 0. When that happens, the secant line becomes a tangent line. So now, instead of having the slope of the secant line, we have the slope of the tangent line. And that's the same equation, except now h is going to be approximately 0. So it's going to be the limit as h approaches 0 of that equation that we had before. Okay? So this is the slope of the tangent line. And if I were to ask you, hey, find the slope on the graph exactly at the point 1, 1, that's what you have to do. It's like drawing a tangent line right there and finding the slope of that tangent line. Okay? Okay. So here we go in more like, formal form. Okay. So find the slope of the line tangent to the curve of this function at the given point. So the curve is y equals x squared at 2, 4. Okay, so right there. Okay. So here's what we're going to do. So what is f of x here? Oh. So, okay, there are two ways to do this. I'll show you the first way. So f of x, oh my God, why can't I pick a color? So f of x is x squared. F of x plus h is x plus h squared. Okay. So and then let's simplify this out. So x squared plus 2xh plus h squared. Okay. All right. So the slope here of the tangent line is going to be the limit as as h approaches 0 of f of x plus h minus f of x over h. So let's see. This is the limit as h approaches 0. What was f of x plus h? It's that thing that we just found. Minus f of x. F of x is x squared. Yeah. 2xh. Yeah. I said that and then I wrote something else. Over h. Okay, now we're going to do some simplifying. So take a look. X squared minus x squared will go away. So this is the limit as h approaches 0. 2xh plus h squared over h. Can we factor out an h? We can. So the limit as h approaches 0 of h 2x plus h over h. The h's disappear. So now I can plug in h as 0, right? So this will be 2x plus 0, which is 2x. So this is the slope of the tangent line. It's 2x. The plus h doesn't. Here, you now put 0 for h. Okay, so now we wanted the slope at the point 2, 4, right? So at 2, 4, x equals 2, right? So the slope of the tangent line is 2 times 2, which is 4. Okay? So if I were to draw a tangent line there, the slope of that line would be a 4. Okay? Right? This? So we're doing this at the point 2, 4. Here x is 2, y is 4. So if this is 2x, then 2 times that x, 2 is 4. So you plug this x into the 2x here. There is no, it doesn't call for y. The recipe just calls for x. It's just 2x. Yeah. It's a very, right? Because at the point like 1, 1, I mean, they're like, it's a coincidence. Okay. All right, let's do another one. X squared plus 4 at negative 2 comma 8. So again, so f of x is x squared plus 4. F of x plus h is x plus h squared plus 4. You can do this whole thing like within the fraction. I like to do a little bit like preliminary work. So x squared plus 2xh plus h squared plus 4. Right? Okay. So we need to find the slope of the tangent line. This is equal to the limit as h approaches 0 of f of x plus h, so that's what I just found, plus 4, okay, minus f of x. And what's f of x? X squared plus 4. All over h. Yes. So take a look. Here I have x squared minus x squared. These will go away. Also 4 minus 4, those will go away. So what I have left is 2xh plus h squared all over h. This is the limit as h approaches 0. Factor out an h. 2x plus h over h. This goes away. So now the slope of the tangent line is, I put the 0 into h now, right? So look, it's the limit as h approaches 0, 2x plus h. I put the 0 in, so what do I have left? 2x. But I need to find this at the point negative 2 comma 8. So now the slope of the tangent line will be 2 times negative 2, negative 4. So when I draw a tangent line over there, the slope of that will be negative 4. Okay, now let me show you another way of doing it. Okay? Okay, so let me do method 2. Method 2 is you plug in the 2 from the beginning. Okay? So at x equals 2, negative 2, what's f of x plus h? This is f of negative 2 plus h, right? Because x is negative 2. So you do it from the beginning. So now, what is that going to be? Right, so let's see. So f of negative 2 plus h is negative 2 plus h squared plus 4. 4 minus 4h plus h squared plus 4. So this is 8 minus 4h plus h squared. Okay? Now, what we need to find is this. The limit as h approaches 0, f of x plus h minus f of x over h. That's what we had. What is x? Negative 2. So this is f of negative 2 plus h minus f of negative 2 over h. Yeah? Okay. This is the limit as h approaches 0. Okay, f of negative 2 plus h. I just found that in the black ink. So 8 minus 4h plus h squared. Minus, what's f of negative 2? When I put negative 2 in here, it'll eventually be 8 over h. Okay, so now let's simplify this. This is the limit as h approaches 0, 8 minus 4h plus h squared minus 8 over h. 8's go away. Factor out an h. Negative 4 plus h over h. Cancel out the h's. The limit as h approaches 0, negative 4 plus h. Plug in the 0, what do I get? Negative 4. Okay, so you see how I arrive at the same answer? This kind of, you do the plugging in before, this you do it after. Is one better than the other? No. Is one more preferred than the other? Also no. You just do whichever one you like better. Okay? Yeah. Huh? Okay, so let's go ahead and do a couple more. Let's do this one. I'm going to do it using the first method. Okay? All right, the equation at any point. So again, I need this. F of x plus h with the limit. Minus f of x over h. Okay, so let's do that. I'll do it before here. So what's f of x plus h? X plus h squared minus 4 times x plus h plus 2. Okay? All right, we're going to multiply this out. I'll race you to it. Ready? On your mark? Get set? Okay, go. Let's do it. Okay? So I actually wrote it out. It's kind of inefficient to write it out here and then write it out again. If you want, you could just, do this whole thing in here. That's totally up to you, okay? In fact, eventually, that's what we'll do as we remove all the crutches. So this is x squared plus 2xh plus h squared minus 4x minus 4h plus 2 minus f of x. Can we just plug that in with, changing all the signs, right, in one shot? So it's minus x squared plus 4x minus 2 over h. Yeah. No. It's minus because they have to cancel, right? Okay. So x squared minus x squared will go away. Minus 4x plus 4x plus 2 minus 2. So when you do this, it's black magic, right? Every single time this f of x that you put here is going to cancel out. And then you'll have this. So now I have the limit as h approaches 0, 2xh plus h squared minus 4h over h. By the way, what happens if I plug in h now? I get 0 plus 0 plus 0 over 0, indeterminate. That's why we have to factor stuff out, okay? So limit h approaches 0, factor out an h, these go away. Now that the problems went away, now I can plug in 0 for h, and I get 2x minus 4. So the slope of the tangent line is 2x minus 4. Okay, let's look at the directions. This one had asked us to find the equation of the slope at any point. When it says at any point, you leave your answer in, expression form in terms of x. All right, so you're done here. If it had said, at the point blah, 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 then you would have to plug it in. Okay, let's plug this one in. So slope of the tangent line is the limit as h approaches 0, 2 over x plus h minus 2 over x over h. Okay? Okay, now we need to solve this because if I plug in h equals 0, I get 2 over x minus 2 over x, 0 over 0, so that's not cool. Okay, so here's what I need to do. Okay, the denominator here is over 1, correct? Okay, so here, multiply by the mega common denominator. So between the x plus h, and the 1, it's x times x plus h. That's the common denominator between all three of these. So you multiply the top and the bottom by the same thing. Now, distribute, distribute. So this times the first fraction, the x plus h's go away, and I have 2x. So this is the limit as h approaches 0, 2x minus. Now the x's cancel, so I have 2x plus h over h, x, and then x plus h. Okay? So we're going to distribute this. So I'm going to get negative 2x, negative 2h. So let's see what we have. The slope of the tangent line is limit as h approaches 0 of this. Yeah, right? So then those cancel. So I have negative 2h over h, x, x plus h. H's will go away every single time. If the h's don't go away and you're not allowed to plug in 0 because you're still getting 0 over 0, it's human error. We did something wrong. So now this is the limit as h approaches 0, negative 2 over x, x plus h. Now we plug in 0. X plus 0, so it's just, negative 2 over x squared. Okay?
Press start.